First up, we have Keith.
Hey, hello. I am here to talk to you guys about how to find Python near you. This is going to be an incomplete guide, and it is likely outdated because a lot of these sources I use are aggregators, and as conferences update, they slowly get out of date themselves. But we're going to do this. You're at PyCon US, so congratulations, you have found Python, and it is near you. But there's a lot of other conferences that take place. So we've got some aggregators that do a bunch of collections of different conferences or events of different things, and that'll drop into sort of a continental level conference organization where you have PyCon LATAM, the Python Asia Organization Conference, PyCon Africa, EuroPython, and then you have a bit more country level conferences. And then you also can go into regional level conferences. There are a lot, but there's also meetups. That is another way you can find Python near you. The Python Software Foundation has a pro network where they are an aggregator of different Python meetups. And if you're a part of that network, you can have the meetup fee processed by the Python Software Foundation. And there are a lot of groups in a lot of countries, and that's another way you can find Python near you. There are also user groups if you want that flavor. There's also just topical domain communities like PyData. There are identity communities like Black Python Devs and PyLadies. There are online communities like the Python Discord, the Python subreddit, or other places. There's a lot. And so that makes for a very busy calendar, but that's kind of a methodology to find Python near you. Look for a conference or event that's nearest you, but at a top level, and then start moving towards more regional things and more local things. I have lied. This is not a talk about how to find Python near you. I want to talk about birding because I love birding. One of my favorite things is the Merlin Bird app, which has a cool feature called Sound ID. Now, Sound ID will take the song of a bird and tell you what bird it is. And when you look into it and look a little closer, it says that Sound ID is trained on recordings and uses a spectrogram, uses computer vision tools. Let's dig into this more. That's Python stuff, isn't it? Yeah, okay, we have found Python. I have lied again. Sorry. This is a talk about hobbies and finding Python in your hobbies. I want you guys to go to your local communities and enjoy the hobbies that you have. And as you do so, because Python is in a position where it is everywhere, it'll be pretty easy to find Python in your hobbies. And when you do that, I want you to go and find the people who have made projects and then bring them back to events, be they meetups, online communities. I want you to ask them questions because I really want to find Python near me, and I want you guys to bring it towards me just through all of your individual hobbies. I love birding, I love getting into orchids, I love lots of things, and I don't have to struggle very much to find Python around me. And I would love for you to enjoy a hobby and love something someone has made, and then tell them that. And then tell them that there's an audience of people who really want to hear more. So, thank you. This is a talk about hobbies and Python near you, and hopefully you can bring it near me. Thank you.
Thank you, Keith. I'm sure many of us have found lots of Python near us at this conference. Next up is Chris Ariza talking about a very important command.
Thank you. Welcome, everyone. Today I'm going to share with you one command to find the most vulnerable Python package on your system. So I promised you one command, so I'm going to go ahead and start with that. You can use UVX to do an ephemeral installation of Fetter, then use the audit subcommand and just give it the little flag CVSS. I'm going to talk about what this does. I'm going to show you an example, but I thought I would give you the one command to start. So I, like many of you, are concerned about security in the Python ecosystem. And there's been countless stories of compromised packages in the Python ecosystem in the last couple years. We've seen over and over again malicious actors compromising packages and threatening the supply chain. And in fact, we've had a number of great talks today talking about many of these incidents that I show here. So this led me to want to develop a tool to find packages with vulnerabilities on a local system. And this tool is called Fetter. This is implemented in very efficient multi-threaded Rust, so we get some really nice performance from this tool. So Fetter finds all of the packages. It takes a sort of bottom-up approach. Rather than using a requirements file or a lock file, it searches from the ground up and finds all packages. So in doing so, you can find things that might have been lost in some abandoned project, some abandoned virtual environment, or some things installed already on your system that you may not know are there. Fetter has broad functionality. It can enforce allow lists. It can monitor organization-wide package exposure. And as we're going to see here, it can help you find the most vulnerable package on your system. So how do we measure most vulnerable? Well, for that, we have a tool called CVSS, or the Common Vulnerability Scoring System. What this does is, given a specification of the characteristics of the vulnerability, you're able to derive a number, and that number, generally between 1 and 10, gives you a sense of how great the risk or vulnerability of that vulnerability is. So there's a number of places where you can get CVS scores. The NIST National Vulnerability Database is a really nice one. The open source vulnerability database is also really good, and that's what Fetter uses here. So what we're going to do is we're going to find all Pythons on a system, especially Pythons associated with virtual environments. And from them, we're going to find all site package directories. And there we're going to take all the packages, we're going to look them up in OSV, and then we're going to find the highest CVS scores on our system. And we're going to do it with one command. So here's our one command. I'm going to try this on my system. Now, you'll note that my command line is just a little bit different. I'm using a cache. This takes about 30 seconds on my machine. I have a ton of virtual environments. On your system, it might be a little bit different. But I can go ahead and run this, and it's found, oops, that's not the one I wanted first. Here, let's try it again. There we go. There's the top one. I have an old version of PyTorch here that has a CVSS 9.8 on my system, which is pretty high. And we can see Fetter nicely gives you some links for more information. It gives you the whole CVSS vector, and it gives you the CVS score. So that's pretty cool. As I incidentally showed before, if you want to set a minimum CVS score and find all packages that are at that level or above, you can simply provide an argument there. So now I can do what I did before. Say I want to find all CVSS packages that scores at 9.4 and above, and there we see two things. I have both a PyTorch with a 9.8 and a Lott LLM, which was one of the screenshots I showed you before, with a CVSS of 9.4. So what do you do when you find that you have vulnerabilities on your system? Well, because that just focuses on the vulnerabilities, you might need to find out where they are. And you might have these packages in multiple virtual environments scattered across your system. So you can use the Fetter search command to match a pattern. And if I want to find just where I have this PyTorch installed, I can use the search command like this. If you want to go further, you can actually purge and remove those packages immediately with Fetter directly. And again, this will find that targeted package in every virtual environment and nicely remove it for you. So you can pip install Fetter if you want to try this out. Fetter can do this as well as many other things. And I hope you find it useful. Thank you for your time.
Thanks, Chris. Glad to see a bunch more people coming in. I hope you enjoyed the walk. Everyone else has caught their breath, so now they can actually laugh, which is a great sign. So I've been told that using LLMs can make you do things really, really fast, and Simon promised that he could do something in 30 minutes, or a 30-minute talk in 5 minutes. So he's going to do that now.
So here we go, 6 months of LLMs in 5 minutes. 6 months ago was November. We had the November inflection point. A whole bunch of models came out, and things got really interesting. and the best model changed hands 5 times just in that month of November. I test models by asking them to generate an SVG of a pelican riding a bicycle, because bicycles are hard to draw, pelicans are hard to draw, pelicans can't ride bicycles, And no AI lab would possibly be stupid enough to optimize for this. This is a stupid thing for your model to be able to do. So at the start of November, the best model in the world was Claude Sonnet 4.5. It drew me that pelican on that bicycle. In that month, we had GPT 5.1, better pelican and bicycle. Gemini 3, really quite impressive. GPT 5.1 Codex Max, they released that one in a hurry to beat Google. Something went a bit wrong, it's not so good. And then Claude Opus 4.5, which was our best model for a couple of months after that. And the pelican's facing the other way, and the bicycle's not great, but still an improvement on Sonnet. But really, the big news in November was that the coding agents got really good. We have Codex and Claude Code. They'd both been out for a while. Both Anthropic and OpenAI spent the whole of 2025 optimizing for code, and November is when that started to hit. And then we all went on holiday. Oh, also in November, the first commit to this obscure project called WA Relay. We'll get back to that in a moment. In December and January, we all went through a little bit of LLM psychosis. We had these new models. Got a bit ambitious. My LLM psychosis is I decided to rebuild JavaScript in Python. So I have a pure Python JavaScript interpreter that I vibe coded up, and then I ran it in Pyodide, in WebAssembly, in JavaScript. It's JavaScript in Python and Pyodide and WebAssembly running in JavaScript. Does anyone need a half-assed, buggy, slow version of JavaScript full of security holes? They do not, but it was kind of fun to see what it could do. February, WA Relay from earlier turned into Claudis, turned into Claudebot, turned into Claudebot with lowercase, turned into bot, turned into OpenClaw, and it took over the whole world overnight. It was, for a project that was where the first line of code was written in November, it's kind of extraordinary how fast this thing grew. I'm sure everyone's heard the buzz around OpenClaw. It's your personal digital assistant. We now have a generic term for this because there's OpenClaw and NanoClaw and all of the other claws. It's called a claw. I love this. I love when new terms appear. And in fact, Mac Minis sold out across Silicon Valley. And a friend of mine said it's because it's a digital pet. Everyone's buying an aquarium for their claw to live in, which is lovely. You know, my preferred explanation of claw is this is 2004 Spider-Man 2, Alfred Mullen and Doc Ock. Each of these claws in the plot is an AI claw, but they're under his control because he has an inhibitor chip in the back of his neck. And as long as nothing damages the inhibitor chip, they won't turn evil and destroy everything and take over. That's all I have to say about that. Also in that month, Gemini 3.1 Pro came out with a suspiciously excellent pelican. Look at how good that pelican is. It's even got a fish in its little basket. And then Google put out this promotional video where they already had a pelican riding a bicycle and a frog riding an old-timey bike and a giraffe in a little car, and they had a flamingo on skates and a turtle on a flipping a skateboard and a dachshund in a stretch limo. So they kind of totally trashed my benchmark. Like, it's over at this point. But I am getting really good pelicans now. Fast forward to April. Can you believe that was just, last month? Google released Gemma 4, the first open weight model we've seen from a US lab that's genuinely really good. This ran on my laptop. It's an 18-gigabyte file. And that's quite a good pelican riding a bicycle. Like, this is something my laptop can now do. The reason this was so exciting is that the Chinese AI labs have been running rings around everyone else with their open weight models. And also in April, Chinese lab GLM released GLM 5.1, a 1.5 terabyte open weight model. So you can run this if you can afford $100,000 worth of hardware. That one did a really good pelican riding a bicycle. Like, that's beautiful. It got overambitious. It animated it, and this happened. The pelican is still up there floating in the top left. And then someone on Blue Sky said, look, the pelican, they're obviously training for the pelican. I demand a North Virginia opossum on an e-scooter. And I got this. And it says, cruising the Commonwealth since dusk. It's got a little sparkling earring. When it blinks, its eyes fall off its face, but still, kind of amazing, right? This is getting pretty good. Also, Qwen 3.6, another model that runs my laptop, did a better pelican than Claude Opus 4.7. So my laptop is now outperforming the major models. Gone from that to that. Coding Aim's got really good. That's my blog.
And remember, if it doesn't say micro machines, it's not the real thing. All right, we're pivoting over to Ned. His talk is titled, Silence is Golden.
Hi, I'm Ned Batchelder. I just want to say that the title of my talk is not a commentary on any of the previous lightning talks. Let's say you have something to say. Should you say it? Let's talk about the Pac-Man rule. We all know about the Pac-Man rule. It's often discussed at the beginning of PyCon. The idea is that if you're standing in a circle, you should leave a space open so that someone new can join the group. It's welcoming, it's inclusive. It lets people get into what might have looked like a closed place. Let's talk about time-space duality. Whatever happens to space can also happen to time. Let's say that you're in a place where people are talking, and someone starts talking, and they talk for a while. And then someone else starts talking, and they talk for a while. And someone thinks, I would like to talk, but I don't see a way to do it because everyone else is talking. And someone else talks for a while, and then someone else talks for a while. If we keep a little bit of silence, we've left open a space for someone to get in and talk. That's the time-space duality. Now the person is happy, they can get in and talk. What we do for space as a Pac-Man, we can do for time as a Pac-Man. It's hard to be quiet because you have ideas, and they seem really good, and you want people to hear them. This is a flow chart about thinking about why am I talking and should I talk. And notice, by the way, that when you get down to the part where you're allowed to talk, it says, please be concise. I did not make this chart. I saw it first on a presentation that Georgie did, but it's out there on the web, and there is actually long articles that go into all of the thinking about, let me think about why I am talking at the moment. What am I hoping to get out of that? And I encourage you to go and read it. Some people speak really easily, but some don't. So we should leave them time. Leaving time is like leaving space. Quieter voices can be heard. More voices are better. But silence is awkward. It's very tempting to fill it. You have to be patient. You might hear something new. Inclusion is important. Python, we say, is for everyone. But only if we leave space for everyone, and only if we leave time for everyone. Thanks.
The air conditioning in here sounds really interesting. Only just discovered that. Thank you, Ned. And now we have Eric, who's going to tell us about managing waves of contribution.
Yes. Hello, my name is Eric. I'm here to speak to you concisely about GH Profiler. For a long time, my issue in PR comments looked like this. Thanks for the quick fix. Thanks, humans that I know. Thanks, I did this and there's nothing more. Thanks. But recently I've noticed myself writing more of this. Are you a bot? Bot? Are you a student who thinks they're submitting PRs to their own repo? I don't curse very often, but I've been driven to that. And here's an attempt to reach out in case the person's a human. You're either a GitHub spam bot or you're a human running a bot. You open the same PR across other repositories, none of which have any need for this. Please stop doing this. You're hurting open source, not helping. I want to interact with humans. I don't want to interact with bots. And I don't want to spend much time interacting with humans who are driving bots. So I built GH-Profiler, and you can use it as a tool through UVX, or you can pip install it and then just use it as the command. It does currently require the GH CLI tool for most of the functionality. So running GH Profiler anywhere on your system, GH Profiler against my username and the concise version, it looks at three things. It looks if there are any concerning things about that user's profile on GitHub. Are there any concerns with their recent PR activity? And are there any concerns with their recent issue activity? And these are the things that I go to people's GitHub profiles to look for before deciding how much to interact with them. So this is the full version. It looks at how old is the account, do they have some meaningful profile information, how many PRs have they been opening, what's been happening with those PRs, how many issues have they opened, and what's been happening with those issues. So this is a more problematic user. This is some kind of AI entity that I came across, and this is what its profile looks like. There were some concerns with the profile information, no concerns with the PR activity, but significant concerns with the issue activity. Running the full version shows this. It's a newer GitHub account. There's some information which is helpful. They haven't been opening PRs, but they opened 72 new issues in the last 21 days, and all of those were the identical same issue across multiple repositories. So this is not, I'm going to close this because of this information. This is the context for deciding how much time to invest in this contribution on my repository. So running GH Profiler within a repo, you don't have to use your username if you're deciding what to do with a PR or issue. Within a repo, you can just give GH Profiler issue or PR number, and it will figure out the user and run that profile. You can also generate a workflow. So you can run GH Profiler -- generate workflow, and it generates a GitHub action that will automatically run GH Profiler whenever someone opens a new issue or PR in your repository, and the profile output will be written as a comment on that issue or PR. And so that usage does not require the GH-CLI tool. And this is what it looks like. So I'm using it on the GH Profiler repo, dogfooding, and so I see my profile a lot. And so it's kind of nice to see this. This is the kind of stuff that I used to have to click out into the user's profile to find. Closing thoughts, open questions. GitHub shows engagement, famously. This kind of stuff, all shades of green. GH Profiler shows the quality of that engagement. Is that activity green flags? Is it yellow flags? Is it red flag activity? So my big question, what kinds of information are we using to decide how much to engage with new contributors? What if that information was made visible all over GitHub? This is pre-1.0, so there's lots to be refined if it were to be used widely, but it is already useful to me and some other people. So if you want to try it out, run UVX GH Profiler, run it against your username. Feel free to join the discussion, open an issue on the GH Profiler repo, and I'm smiling because be aware that if you do open an issue, you'll see your profile as well. So I'm around the rest of the conference and through sprints. I'm happy to talk about this anytime. Thank you.
Thank you, Eric. Eric is one of the most human humans that I know, and fitting package. Our next talk is by he's going to be talking about money, 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 money.
Yeah.
Thank you.
Okay. Yeah. Me again. Your Python comedian. I'm KwonHan, your comedian for Python. Your Python salesperson, but not good. One of your friend Pythonista. Last PyCon US, I did a writing talk, one bagel to please them all. Maybe some of you can remember this one. But the problem is, you did it too much. Today, yeah, we don't have no bagel. It's okay. Just copy is fine. Anyway, yeah, we need money. Money, 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 must be funny. Money, 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 being money. It's a rich man's world. Yeah, as you know, learning Python isn't free. Learning Python has never been free. PyPy, PSF, PyCon US, everything needs money. Yeah, but I'm free. I'm free to all Pythonistas. So, from the start, I'm KwonHan. In Korean, it also means permissions. With given my name, my grandpa did, I became SRE. My daily job is SRE with unlimited permission. I'm good at that. I know that because I can come to PyCon US with the impossible 2-week vacation. So I need to use my SRE skills to make money. We need scale out, not scale up. There is money. Yeah, you know that. Memory storage is getting expensive now, so it means there is just money. Automotive, healthcare, pharma, airline, travel, yeah, so there is money. Retail, energy, logistics, also there is money. Biotech without Python, you can think about that. So there is money. They are using Python. I heard some company using Python heavily with multi-billion net worth, but doesn't support Python. I know you might plan to do that kind of consulting, right? Cold mail doesn't work. Yeah, I send thousands of emails to all the companies. That doesn't work. So we need inside man. If you consult them, yeah, please connect them to the PSF. Let them do the right thing. Also, we need to geographically as well. Yeah, donate to the Euro Python Society, donate to the Python Asia organization. Also, local entities. Because in the world, nothing can be said to be certain except deaths and taxes. I'm Korean, but as a PS board member, reading US laws. This year, US tax law changed. So $1,000 per person tax deduction is possible now. Also, you can get tax deduction for each country if you give properly. We need your help. At this time, yeah, bagel is okay. But next time, talk with the bagel in the morning, you'll be fine. Thank you.
KwonHan.
Yeah.
I'm normally the one doing the ABBA at PSF karaoke.
Okay.
We have KwonHan, our ABBA karaoke person, our tax advice person, and somebody making commentary on the lack of free breakfast this year at PyCon.
Yeah.
Multi-talented. Thank you so much. And now we have Sophia with something I've never seen in Python, but you're about to discover along with me.
I do actually believe you've probably seen this because it's actually a little quirk of Python that comes out of something that we probably use every day and you probably don't even realize it. So I'm here to talk to you about something I affectionately call the daisy operator. So let's start with the concept of star unpacking. You've seen this probably a million times before. It's an easy way to just get the beginning of something, the end of something, and then everything in the middle goes into that B, right? Well, take a look at that B. Take a look at star B, comma. Let's change that a little bit. Let's instead just use that as the operator itself. And this is what I call the daisy. And we'll talk about why it's the daisy here in a moment. But this is unequivocally proof that there is art in Python simply without you even realizing it. As you can see here, by executing this command, we simply break down that string into a list. The daisy operator is star unpacking. It's just into a single variable. So why am I calling it the daisy operator? Well, it's simple. Because this looks like that. Very simple. It basically just looks like a cute little daisy in your code, ready to make your day a little brighter. I've heard some people say that this is disgusting, and I'm like, how can this be disgusting? This is a cute little flower. So let's talk about usage of this tool. So normally when you want to get keys from a dictionary, you're basically just doing dictionary.keys, but if you notice, you'll get a dict keys object. And if you want to turn it into a list, then you have to cast into a list. Well, what if we just apply that daisy operator and just get the list? And we can take this a step even further by changing the name of the underscore to keys, and now we know exactly what we're getting is the keys. And we can assert that this is the same thing Because if I were to take the keys from that daisy operator and then compare it to my dict's actual keys, we see that it asserts without an error. So let's see a practical demo of this, because who doesn't love a demo? So this is my PyCharm. Let me actually get over here. There we go. And let's say you have a project where you're working on JSON, and they are like, okay, we have languages here, but it's a list, and we also want to be able to support dictionaries. And the dictionary is going to contain the language and its version. Okay, well, let's compare this and take a look and see the current way we would do things. We would basically have to see, okay, is this a dictionary, and try and get the keys from that dictionary. And then anything else we have to just treat as a list. And we can run this, and we see, boom, it works. Okay, cool. But what if, there we go. What if I go to my second example here, we look at using this daisy operator. Same code, except instead of explicitly getting the keys from the dictionary, I am just using the daisy operator. It executes exactly the same way, except you know there's the difference here. It's not a dict keys, it's a list. And you might be thinking, okay, Sophia, this is great. It only works on objects in Python natively. Well, that's not necessarily true. Anything that implements iter and next can use this paradigm. And I can show you that by simply, come on, there, for whatever reason, my mouse is being weird. There we go. If I execute this, I see, look, this is a custom class I built called myIterable. And it works with the daisy operator just simply because I implemented the iter and next. So let's get this back over to my slides real quick. And so, in summary of the daisy operator, it's a fun little quirk about Python's unpacking, but it's powerful because it works with any iterator or next as long as it's implemented inside of your code. It creates a list with no casting required. It's literal proof of art in Python because why else will this exist? And it's actually really precious. Please do not patch it out. Thank you, and shine on.
That was incredible. I think I will be using the daisy operator to make things more elegant. Thank you. Next, we're going to be learning about things that should obviously be in 3D, things like a business card. So I'll have Jason take it away.
Thank you. Hi, yeah. So I made a 3D printed business card, and I'm going to show it to you. So hi, my name's Jason. I work in IT. My day job is with a community college here in California. But I was told that you can come here and talk about hobbies, so I'm going to be talking about my 3D printing hobby. I've been doing that for about a year or two. Are there any 3D printing hobby people in here as well? I imagine there'd be a few. So I made, this is my very first PyCon, so I made a 3D printed business card to bring here to force myself to talk to people, start conversations, and just have something to do. So yeah, it's something interesting to show off here. So in learning 3D printing, I was doing that, printing stuff. I started doing my own designs, learning CAD, which was new to me. I had this idea. I saw like a reduction gear system, I think in a museum when I was a kid, one of these ones where it starts and it goes down to a chain and it's encased in concrete and must have stuck in my head. I've always had that idea in my head. And so I put this together. It's just sort of traditional CAD design. I used Onshape for this. To make this, so I made each, the gears and the housing as different parts, and then in Onshape you can do an assembly, which was really exciting for me to put the things together. So I got this to where I was happy to bring it here, and so that's where we were. At this point, this is a very cool 3D printing thing, but not a Python thing at all. So I thought, how can I get this, smush it into Python? So I took the step file, which was Onshape helped me create with the different parts. The step file has them assembled together in that screen I showed you. And I put the step file into a GitHub repository, and I said, well, what kind of Python can I throw at this to help me look into it and track it more like a software thing, something more that I'm used to? So playing around with that for a while, I was doing things like just getting, I don't really understand how step files work or the gearing works. So I put it in there and tried different Python and Python tools to see what I can get out of it. So things like getting an exploded view of the assembled file. I have my GitHub for this project on here. I didn't want to tempt the demo gods to do my animated explosion GIFs in the demo, but if you go to the repo, you'll see them on the README. Yeah, with a little bit of work, I got some really interesting results in the repo, and it's been really fun. I use that to generate like explainers, explain like the different gears and how they go down, and do the meshes. Some of it sort of automated, some I had to like coax it along the way. And yeah, that's all been just different Python tools. What's been really fun also is all of this, it just builds, you can run it locally when you're running it, but I set it up to work with GitHub workflows. So when you make changes, it kind of goes through a process of deconstructing those step files, getting the different shape files, and doing different fun things with them. So you may have seen this one, the animated GIF, the gears are spinning at, I think, close to what they should be based on how fast you would be spinning it. But you can see that kind of overlap, so that's something I need to fix. If that bothers you too, you can take a look at that GitHub repo and try it, see if you can figure out a way to fix it. And the screenshot should be rendered, or they might break, and we'll have to figure that out. And now the pause for animals. This is my first PyCon. I've been to a few talks, and there's animals seem to appear at slides. So I wanted to pause here and show my animal. My mom asked for a 3D printed cat toy for Christmas, so I did design that. And that was the first time I used Onshape to take different parts and put it into an assembly, which was really exciting. The 3D printed business card, the Onshape assembly has like rotating gears and like the gear ratios, so a little bit more advanced stuff, but this was a static assembly. So I threw that step file into this project, and it did another exploding GIF that's also in the repo. And this was a good excuse to show my dog, who helped me look at it. And this was, a side note, as a hobby, this was really fun to put. My cat's mom did not like it, but a few cats around the world have enjoyed it, and some other cats also don't like it. So yeah, it's just a tiny plastic fun thing to play around with. I'm sure there's industry standard ways. I maybe have some blind spots or stuff that, paid things like Onshape has version control, which I haven't got into yet because I just used the free one. But this was like a small scale version to sort of try that stuff out and have a fun time with it. And then see if I can do stuff like more software things like reproducible builds or like unit tests that finds maybe physical collisions, interesting things like that. Oh, and then also I'm just sort of like, with open source licensing, I kind of know how it works for code, and then Creative Commons for like creative works. I'm interested, like, how does that work with other ones? So thank you. My name is Jason, and that's my repo. Thank you.
Hey, thank you for that. Hey, so I've seen some people asking on the internet about the auction after this. It's not a 15-minute walk to get to where the auction location is, so you don't have to start walking out immediately. It is just on the other side of the hallway outside here. So it's a short walk. You won't miss the auction if you stay to the end of the lightning talks. So you should do that. But first, Jared is earwormed me with my third favorite Ringo song.
Hello, everyone. I'm going to tell you how my friends and I all felt like we lived in a Python submarine, also known as enabling 150-pound submarines to drive themselves. So my name is Jared. This is my first PyCon. I've hosted here. You are getting a sneak peek of some training wheels or flotation devices that might come into place later. So why a submarine? For competition, of course. Specifically, the RoboSub competition. What is it? It's an underwater obstacle course. You start at the gate at the bottom. You go through a gate. You try to find some buoys and hit them. Try to shoot torpedoes through a target. But the big thing is, it has to do it by itself. You can't do anything. You click it, it starts. You see it go. Has to do its whole thing in less than 15 minutes. And you hope and pray that it comes back up after the 15 minutes are up. So meet Percy, the RoboSub. No relation to a robot on Mars. And this is my team of great friends who made this submarine in college together. So how does it know where it is? Well, it has a camera on board, and it has a machine learning model that we tuned on the obstacles that it was going to see. A buoy of different colors, a gate that it goes to, and it can tell how far away it is by telling, okay, it's this many pixels across the board, therefore I'm this far away. But how does it know how far to go? Well, there's no wheels for it to turn, so instead we have a little sonar at the bottom that pings the ground and it comes back up. So that's how we know how fast it goes and where it actually is. So pip install a library to talk to it, right? Unfortunately, no. Don't try to read that data sheet. That data sheet tells you how to talk to each byte of that sonar is telling you like where it is, how fast it's going. So what do? Well, Python has everything you need already. It's got the serial library and a struct library. So 3 lines. You open the serial port to it, you tell it to read the number of bytes that you need from it, and then you just literally write every single thing that you have on there, and you put a struct unpack at the end. Those things, B, 1 byte, I, 2 bytes, I, 4 bytes, F, a float, 4 bytes. That's it. So how does it move? Well, it has thrusters. So my teammates made printed circuit boards to talk to them. How do we move those? Serial again. You talk to the serial port, you open it, and all you have to do is say, hey, I want it at 80%, turn it to a hex number, write it as a byte array, there you go. So did it work? Yeah, it worked pretty well. So now you know all you need to make a Python submarine yourselves is just import serial, import struct. Thank you, everyone.
Thank you so much. Maybe next time you can model strawberry growth and spend your time in the strawberry fields. I tried. Wah, wah. All right, now maybe we'll get a look at one of those possums that Simon had riding on a scooter. Maybe not on a scooter, but something like it. We have Gabriel giving us our next talk. Thank you.
All right, hello everybody. My name is Gabriel, and I'm here to talk about the possibility to win a bet. So my name is Gabriel, and I work as a volunteer in a wildlife center, and that's has been one of my favorite things to do in the world. And every summer something happens, and I was like, why not, use Python for this? But Willowbrook Wildlife Center is a rehabilitation center for wild animals that we have in Illinois, in Chicago. So some of the animals that I work with are herps, such as, here's Junior and Spike, a Blanding's turtle and a corn snake. But that's not what I'm here to talk about. I'm here to talk about opossums, these cute little guys that we have coming during, start of spring season all the way to October. And they are a handful. But the hardest thing for us is trying to know when they are coming and how to prepare for them. Every year, me and my coworkers, we figured out, hey, let's make a bet and try to predict when they come. But all these predictions are just, we hope they come tomorrow, or Wednesday, or Thursday. They're not data-driven. As a person that studied data science, why not use data science for this? Another picture of opossums. They're adorable. So my question was, how can I use a statistical methodology and machine learning to win this bet? Because why not, right? There's no money involved, just bragging rights. So my first step was to create a simple data analysis, data exploration. By looking first, how does it has been in the past 20 years of data, roughly, what does it look like for us? And we can see that there's a big spike after COVID, so hopefully COVID make people more nice to animals, and they want to come and rescue them and bring to us, which would be great. But also, that's not enough to make any prediction or really a lot of insight. So let's look per month, which I thought was interesting. As we can see, March and April is when we start getting some opossums, and there's a big spike in May and June. But what more interesting is that March and April, because we want to look at when the first baby arrived. If we look by weekdays, we can see that weekends are the big winners. Of course, people are out enjoying the good weather, spend time with their family, so they can see the opossums that are injured and bring to us. And one step further, I would like to see what happens to those opossums. So as you can see, over 4,000 of the opossums we have received are released. Some of them, unfortunately, are euthanized because they are either so little or so badly in shape after accident that they cannot be released to the wild. So my methodology involved using statistical method and LSTM. So I used SORIMA that I learned in college. And when I tried the first time, I had something was wrong. Because it says like, hey, your first opossum is going to arrive in January. But January is winter. There are no babies in January. So after a look, and talked with some of my coworkers, I found out there's some mislabeling. So it's like, okay, one easy way to fix this is setting the probability of any opossum arriving before spring, March 21st, to be 0. That's why we have that 0 probability in the beginning, and then after that, we have the rest of the data. And on the dashed line is when the forecast begins. Next, I use LSTM, because it was like, why not? Let's use something that don't have machine learning. And you can see on the top left, those small circles are when the first baby would arrive. So what are the predictions that my model predicted? The first one, SORIMA, predict that the April 11th of this year would be our first baby. Great. Our STM, I created 3 architectures. The first one, stacked and bidirectional, predicted on March 12th. And then we have just a basic LSTM predicted on April 13th. But how does this model fare? Well, we waited and wait for the first baby opossum to arrive. So we'd like to see how well my model fared. If I could have some drum rolls. So the first baby opossum arrived in April 14, 2026. So my model was 1 day short. So, but I won though, because all my coworkers said was going to arrive. That was a Tuesday, and they were predicting for a Saturday. So I guess I won bragging rights. And for that, I have a lot of pictures to show you about animals. So we have raccoonies, we have a coyote, we have a box turtle, a bullfrog, sandhill crane, turtles, and more opossums. So many opossums. And thank you so much. Thank you, PyCon.
Hey, thank you, Gabriel. And if you were running a bet on which animal would be the first one to show up 3 times during our lightning talks this year, and you bet opossums, you probably won something, I don't know. There's still a bet on which sort of regression analysis will show up for a 3rd time. But first, Lott with tabletop RPGs.
Yes, tabletop role-playing games. Are there any other of the tabletop role-playing games here? I've got a few. That's good to know. We had an open space, and we talked about this, which is my long, sad story, but I'm going to make it short. The tabletop role-playing game problem domain is extremely complicated, because rules are what they are and people write them and it gets all out of control. A domain-specific language to formalize the rules is a crazy idea, and I don't know what caused me to think of this, but I have done many DSL-related projects in my long, colorless, pointless career, and what the struggle always was without Python or some interpreted language like that, you had to write a compiler and a parser and a grammar rules and blah, 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 blah. And you don't need that anymore. You can do the entire thing as just straight up first class Python. So my first example is, this is the sort of traditional thing you read in the rule books. They say 3d6 plus 2, and you figure out what that means. And it's a regular expression. Come on, we all know how the regular expression library works, or we can use the HumRE, the human regular expression variant on it. There's a lot of fun ways, or just write it as Python code. I mean, all I did was define D6 as an object, and everything works, you know, and I didn't have to parse anything because it's straight up code. You know, and it's not rocket science because the whole multiply and add business is just a first-class part of the object definition, so it's not even really complicated to do. It applies widely. There's a lot of other ways you can do domain-specific languages that make use of the Python syntax. My second example is the OpenD6 fantasy rules. Oh my God, this was nuts. Multiple pages of rules, all written in the 80s, so the word a calculator may also help was part of those rules. But, you know, it translates into Python kind of naturally, and all the complicated budgeting and all the things that you have to do to pencil and paper and multiply with the calculator, all taken care of. Who even cares? So almost everything is just, you know, the attribute equals a longer definition. And, you know, that looks a lot like Tamil and JSON and all those other sort of artificial languages. But A, I can use things like the dice thing. And B, I didn't have to even write something to ingest it. It's not like I had to import Tamil-lib or import JSON or something like that. No, it just, the code is the specification, the language is used directly. So DSLs generally are advised as a stupid idea. I've got a great idea, I'll invent a DSL. Now I've got two problems, the original problem and a language to help me solve the original problem, and I have to support now two things. Unless you use Python object declarations, you get a nice declarative DSL. You didn't have to write a parser, and it allows you to think more freely about the problem domain and express that problem domain pretty naturally as code. Thank you.
Thank you, thank you. I have heard rumblings that after the auction, there still may be some crazy people up for gaming at the Hyatt. I see you gamers out there, and thank you for that. Our last lightning talk, and then we can all head over to the auction, those of us who are going, is about the simplest esoteric language by Ariel Ortiz. Take it away.
Gracias. Buenas tardes. Me llamo Ariel Ortiz y vengo de México. Well, I thought that if Pablo Galindo gave the first keynote address in PyCon in Spanish, I could be the first one to give a lightning talk in Spanish. No, just kidding. Okay. A little bit about me. I'm a professor at a university in Mexico, Tec de Monterrey. This is one of my classes. I teach compiler construction, and this is one of the last groups that I actually had last year. And today I want to talk about this specific way of implementing an esoteric programming language. So first of all, what is it? An ESOLang, or esoteric programming language, is an unconventional language that is designed basically just as a joke or as a technical experiment or some kind of art, okay? Instead of having it for some particular use. So we're going to look at this one called HQ9 plus ESOLang, okay? So this was created in 2001 by Cliff Biffle. Okay, and it supports only 4 instructions. Okay, so the first instruction is H. So typically you want to do a hello world, so yeah, that's supported. It also supports an instruction called Q, which is for a Quine. A Quine is basically a program that produces itself, okay, a self-replicating program. Yeah, we got the 99 bottles of beer, okay. And finally, we have a plus operation that increments an accumulator, okay? Interesting thing about this one is that it does increment it, but you don't see any output or anything, so you have to take my word that it does it, okay? So Just a quick note, Quine, maybe you're not too familiar. Basically, it's a program that takes no input and produces a copy of its own source code. So let me show you what it looks, a Python Quine, what does it look like. This is one of the shortest ones that I could find in internet, okay? If you run this directly, you get exactly the same output, okay? I encourage you to check it out, okay? There's a QR code there in all the slides, so if you want to check everything, you can do it over here, okay? This is, I really encourage you, I'm really proud of the code that I wrote because I promise you, it's the best code that I wrote today. So the transpiler design, basically, the HQ9 plus is this compiler takes a source file, we read it, we clean them, but basically we eliminate the white spaces, new lines, and so on, and we iterate over each particular character. We transpile it, okay, to the corresponding C code. We use a C code so that we can produce actually an executable. If you look at the internet for this particular language, you'll find a lot of interpreters, but I didn't actually find a compiler. So here, this is an example of a fully functional compiler. It produces C code, and then the C code is compiled, and then we can execute it, okay? So basically, we compile the C code at the end, and we get an executable. So let me show you actually how it works. So all this is available in a GitHub repository. So let's see the first example. Let me see. This is the first example, just the H, okay? This produces a hello world. So let's try it out. So to run it, yes, we get a hello world, okay? Yes, thank you. Well, there's several, so let me get to this one, which is a little bit larger. Just the 9 produces the 99 bottles of beer. So let's try it out. So let's run it. And this one produces a lot of output, so let's just do a less here. So there it is. Okay, and well, you can do larger programs, okay? I think we're out of time, so I'm just gonna show you the program. So you can put several of these commands, like 9++, HQ, and so on, okay? And well, the source code is available. It's less than 50 lines of code. So I'll put it there in the GitHub repository for enjoyment, okay? Thank you.
Ariel, I've been an HQ9 Plus programmer for a number of years now, and I had no idea how you managed to fill more than 5 minutes on it. He will be running the HQ9 Plus conference next year. Okay. We'll go for all of 1 second. That's all the time we have for lightning talks today.
What do you think? You gonna get yourself some pet possums?
So I'm Australian, and the possums that we have, they live in your roof all through winter, and I've had enough possums in my life, but I've liked seeing them in the talks today. It's been good.
That should do enough. All right. We'll catch you all at the auction, or if not, tomorrow morning, right back here for lightning talks at
8 a.m. If you've been inspired to present a lightning talk, there's no more opportunities this year, so hold on to your ideas, submit them at your local Python meetup or Python conference, or at PyCon US next year, because I'm sure they'll let us back.